Shape from X, one of the core challenges in computer vision. We are going to look at how we teach machine to recover the 3D world using only 2D image data. When we take a photo, we lose depth. A single image is just a flat grid of pixels. Shape from X is a family of techniques where X is a specific visual cue like shadows, motion, or texture that we use to mathematically reconstruct that lost 3D geometry. Each method has its own unique strength and weakness. The first is shape from shading. This uses the brightness of pixel to determine the orientation of a surface. The advantage here is that it can work with just a single image. However, it's often will post, meaning many different shapes could create the same shadow. It's also very sensitive to light changes. If the light move or the object has a weird texture, the math falls apart. Next is shape from stereo, which mimics human vision by using two cameras at a no distance. The big advantage is accuracy. It provides a real-world measurement, which is why it is the standard for robotics. The disadvantage is that it's computationally heavy because the computer has to match millions of pixels between two views. It also fails on smooth, featureless surface like a plain white wall because there are no points to match. Shape from motion is like a stereo, but it uses one moving camera instead of two static ones. The advantage is cost. You can do this with a basic smartphone. It's also how we map entire cities using drones. The downside is scale ambiguity. The computer knows the shape, but it doesn't always know if it's a toy house or a real skyscraper. Plus, if anything in the scene move while you are filming, it creates errors. Then we have shape from texture. This relies on the distortion of regular patterns like a tile floor or a brick wall. The advantage is that it's very intuitive and provides strong cues about the tilt or slant of a surface. The disadvantage is that it's entirely dependent on the scene having a predictable pattern. If you are looking at a messy, irregular forest floor, this technique struggles to find a reference. Finally, shape from focus uses the lens itself. By changing the focus and seeing which part of the image becomes sharp, we can estimate distance. The advantage is that it avoids the pixel matching problem of stereo and motion. It's excellent for microscopes and close-up photography. This advantage is its limited range. It's only work for objective very close to the camera, and it requires high quality texture to detect sharpness and accuracy.